Hey guys, welcome back to Data Every Day. Today we'll be looking at some student data and trying to predict their grade, final course grade, based on a bunch of factors, including alcohol consumption. Alright, let's get into it. So, we'll start off by importing our usual libraries. And we'll get some matplotlib for data visualization and Seaborn. Okay. Now for this data set, we're going to, we're going to need three data preprocessing tools. So from sklearn.preprocessing, we'll need the label encoder, and the standard scaler, and we'll get the train test split from sklearn's model selection. And for our model here, since we're not classifying, we're going to use linear regression. So sklearn.linear model. Okay, there we go. So let's just start a markdown here, getting started. Okay, we'll run that. Whoops, what happened there? What? Weird. Okay. Okay, whatever. Let's load in our data using Panda's read CSV function. And we can get it over here. There's two data sets, one for mathematics grades and one for Portuguese language grades. We'll use the mathematics one for this. So we'll load it in, take a look at it, and we can see there's 33 columns, and G3, this is the final course grade, is the one we're trying to predict. So G1 is going to be the first period grade, and G2 is going to be the second period grade. So my guess is these guys, G1 and G2, will be strong predictors of G3, but hopefully some of this other stuff will also help us predict. So I think what first thing we should do is visualize some of the correlations between the data. So say data visualization, and we're just going to use Seaborn's heat map to plot the correlation matrix as a heat map. So we'll get set the figure size, make it 14 by 12, and then sns.heatmap, and we'll pass in the correlation matrix and turn annotations on. Take a look at that. Alright, and we can see, so it looks like not many of the features are correlated except these guys, first of all. So this makes sense, like what I was saying. G1 predicts both G2 and G3, and G2 predicts both G1 and G3, and looks like G3 even predicts both G1 and G2. So these guys are highly correlated because those are just the course grades. People who are doing well in the course early in the course most likely are doing well late in the course, and vice versa. I mean, people who are doing poorly in the course early in the course will most likely be doing poorly in the course later in the course. So other correlations, you can see that the mother's education level is correlated with the father's education level, which makes sense. And then this is the weekend alcohol consumption, has something of a correlation, positive correlation, with whether or not they're going to go out, and also a positive correlation with the daytime alcohol consumption. So anything else we're seeing here? Negative correlations. So it looks like failures is negatively correlated with G1, G2, and G3. That makes sense, because if they have high grades, they have few failures. And study time and weekend alcohol consumption also are negatively correlated, which makes sense because most likely if students that are engaging in weekend alcohol consumption are losing out on study time. Okay, so let's start pre-processing our data. So pre-processing, and first thing we'll do is we'll check for missing values. So checking for missing values. And the way to do that is data.isNull. Remember, this will return us a matrix of all the places where there's null values. And we can get the sum to find the number of null values in each column. And looks like we have none, so this is a fairly clean data set. So we don't have to worry about clearing or filling or imputing null values. So we can try encoding now, because we have a bunch of non-numeric values here. You can see mjob is non-numeric, fam size on non-numeric. So basically, let's take a look at the data types in the dataset. So just .dtypes, and we can see, okay, we have some integers, but also some objects. Objects here mean string. So let's see. Let's make a list of all the non-numeric columns. So we'll call it non-numeric columns. And we'll use the list comprehension to say, okay, well, I'll start with the for loop. For in, what are we trying to say here? We want to get all the names of columns that have object as their data type. So if we enumerate the data.dtypes, which is this guy right here, this will give us the a list of the dtypes with their numerical indices, and we can use hold on. Right. Okay. So we can use index dtype in this enumeration only if dtype equals object. Right? So and then what we're going to store in the list is going to be the columns evaluated at the index of the dtype. So I think this should work. If we just take a look at what it looks like, there are columns. This should give us all the ones. Right, okay. Alright. So we're going through basically all the dtypes, taking the dtype and then indexing it with the enumeration. And then if the dtype is equal to object, we will store the column corresponding to that index here. So as we can see, any one that has object is going to be stored here. Right. So because this is the list of columns as well. So if we index at columns, we should get only the ones that have object as the dtype. So school, sex, address, fam size, p status. We should skip age, and looks like that happened. There's no age, and then we should also skip medu and fedu, which comes between p status and mjob. P status and mjob, you can see there's nothing in between. So it looks like we got what we needed with new non-numeric columns. So let's see what kind of data is in each of these non-numeric columns. So we are going to find the unique values in each one. We can get the unique values just using pandas unique function. And so if we do for column in non-numeric columns, hold on, it's flickering. We're going to print as an f string the column name followed by the unique values in that column, dot unique. So if we run that, we should see, okay, here's the column name for each of these non-numeric columns, and we can see what kind of data is inside. So for school, there's only two values, GP and MS. I think they correspond to two different schools in Portugal, if I read correctly here. Yeah, two different schools, see? Okay. And a lot of these are binary variables. We can see these features all have yes, no, and these guys also at the top will only have two values to choose from. So for the two values, we can use a label encoder, since there's no sense of, like, it doesn't really matter how we order two values, because saying one is greater than the other is sort of just the same thing as saying one is different from the other. But with these guys, we cannot use the label encoder because we would have to assume some sort of order between at home, health, other services, and teacher, which makes no sense. So here we're going to use one-hot encoding. And the same goes for these four right here that don't have binary values. We'll use one-hot encoding. So I think we'll start with the one-hot encoding. So let's say, okay, notice that all four of these have something called other in them. And that's going to make it difficult, because with one-hot encoding, we're going to make new columns that have the name of the values in each one. So we would have four duplicate columns called other, and that's not going to work for us. So what we can do is go ahead and append on a little indicator at the beginning of each of these columns to give us a sense of which column it's coming from. So what we can do then is, for example, for mjob, right, we can use apply to apply a lambda function that takes in a member or value of the column and it will output that same value but with m appended to the front. So what that, for example, I think this will show. Now everything in mjob has m at the beginning. And so now other has m at the beginning. And as you could probably guess, for fjob we'll append f at the beginning. Now we'll have two different others, one f other and one m other, so that we don't have to worry about duplicate columns when we use the one-hot encoding. So let's set that equal, mjob. And then we'll do the same thing for all four of these one-hot encoded columns. So this will be f underscore. This guy is called reason. So this will be r underscore. And the last one is guardian. G underscore. Okay. So that will apply this function to all of those columns. So now if we were to take another look at the data, we can see that mjob has m's at the beginning of all its values, fjob has f's at the beginning of all its values, and you can imagine reason and guardian also have r's and g's respectively at the beginnings of their values. So now we should probably take another look. I mean, let's take a look at what a dummies matrix looks like for one of these. So let's get the dummies matrix, dummy matrix, for mjob. So pandas.getDummies data mjob. And you can see now it takes all the same examples, but instead of having one column with different text labels, it uses those text labels as new columns and just puts a 1 if that value is present in the example and a 0 for all the others. So that's why it's called one-hot, because only one of them is going to be hot. And the same thing goes for each. So for example 0, the m at home has a 1 and all the others have 0. That's simply because at example 0, the value for mjob is m at home. Alright, so now what we can do is we're going to concatenate all these dummies columns together. So we have the same thing, right, but for each one of these. So we have one for fjob, we have one for reason, and we have one for guardian. And basically we can just concatenate them all together using pd.concat, and we'll store them all in this list here. And we want to specify that the column axis is the concatenation mode. And we'll store that in a new data frame called dummies. So all we have to do now is put each of these inside here, like this. Wait, last one. Okay. And so this should take one of these for each of these four and put them all side by side, and that we can concatenate right back onto our original guy. So if we just take a look at dummies, you can see there's 5 columns for mjob, corresponding to the 5 unique values. There's a number of 5 columns for fjob, corresponding to the 5 unique values. There's 4 for reputation, corresponding to the 4 unique values in reason, corresponding to the 4 unique values in reason, and 3 in guardian, corresponding to the 3 unique values in guardian. So now what we'll do is just put this right on the end of data. So data equals pandas.concat, and here we're going to concat data and dummies, again column axis, and we're just going to drop the original columns from our data set. So data.drop mjob fjob reason, and the last one was guardian. Okay. Oh, what happened? Oh, I didn't specify the axis. Axis equals 1, and also in place is true. Now we'll take a look at data, and we can see, okay, we no longer have those original fjob and mjob columns, but now we have their dummy columns appended to the end of the data set. Okay, so what next? Let's take another look at non-numeric columns. So we're going to have to recalculate it here. So instead of checking that, let's look at the this guy, the unique values in each of them. So now our non-numeric columns are all binary. So this allows us to use label encoding for every one of them. So we'll set up a encoder, that is the sklearn's label encoder, and for each column in the non-numeric columns list that we made, we're going to apply the encoding, label encoding to each column, right? So data column equals encoder dot fit transform that column. So we're going to take the column, fit it to the encoder, transform it, and return it back to the column for each one of the new non-numeric columns. So if we run that, now if we look at data.dtypes, here let me just for dtype in print dtype. Everything is either an int or an unsigned int. So we're good to go. All this stuff can be skilled now, and we don't have to worry about any more problems with text labels. So our label column, the column that we're trying to use, here let me just make a new markdown. scaling. The column we want to use for regression is going to be the final course grade, G3, right? G3 was the name of the column, so we're going to say our Y is data sub G3. And our X will just be everything but G3. Now, as we can see, Y should be a single vector of values. I think they take on a range of 0 to 20, 20 being the highest grade, 0 being the lowest. And X should be everything except that. So before no, I didn't actually check. Our data has 63 columns. X should have 62. And so it does. Fantastic. Alright, so let's see now. Okay. We're going to scale X. Now I might as well put this up here. Right. We're going to scale X using sklearn's standard scaler, which will give every feature unit variance. So scalar is standard scaler. And X is now going to be equal to scalar.fit transform X. However, this is going to return a NumPy array, so let's turn it back into a data frame to make it easier to visualize. And we'll keep the columns as they were. So run that. Now we take a look at X. Everything has been scaled between 0, so scaled to have unit variance. Alright. And it shouldn't matter for the one-hots, right? Because it's still going to have the same value every time there's a 0, and the same value every time there's a 1. So now we can train our model. So let's go ahead. Training. And if we remember, first we actually should split our data, right? So we're going to get an xtrain, an xtest, a ytrain to ytest using sklearn's train test split. X, Y, and we'll say the train size here will be 70%. Alright. So we'll run that, and then we're going to say our model is going to be linear regression, and we'll fit it to the train set. So xtrain, ytrain. Very nice. Now for the results, I'm going to print as an f-string the r² value for the model, which is just model.score xtest ytest. So we're going to evaluate it on our test set. Let's see what we get. 80, a value of 0.8 as our r² value. So this is pretty good. This is saying, based on all the features, we are able to get a pretty good estimate for what the final course grade will be. And so I guess that's it. That concludes today's video. If you enjoyed the video, make sure to subscribe and leave a comment in the section below. I'll see you guys tomorrow. Have a great day.